Hello everyone, this is Sangeeta, Assistant Professor, EC Department, SNS College of Technology, Coimbatore. So in this video, I am going to cover the image sampling and quantization. Before that, let us have a small recap about the previous uh, video session. So in the previous video, we discussed the fundamental steps and the main components of digital image processing. So the fundamental steps are image acquisition, image enhancing, restoration, segmentation, compression, and object detection description are the fundamental steps involved in digital image processing. And the basic components required to implement all those things are image sensing devices, CCD, and CMOS and ultrasound scan devices, and hardware devices, software devices, that is OpenCV, Photoshop, and MATLAB are the software requirements for process the signal in digitally. And today we are going to cover what is image sampling and quantization. So, image sampling and quantization, that is spatial discretization, that is the basic difference between analog and digital. Or analog means the signals are continuous in time, and digital means discrete value. So image sampling means spatial, that is I already told that there are two domains, spatial domain and frequency domain. And image sampling means spatial discretization of a continuous image, that is selecting the discrete pixels in spatial domain, determine spatial resolution in the digital image. And image quantization means rounding off the spatial discrete numbers, that is amplitude discretization of pixel values. So the mapping continuous values to the different intensity level. So it determines the color and gray values of digital image. So the image formation, generally the image formation is the continuous image. Suppose if we want to that is analog image, suppose if we want to convert it into digital, we have to do two things, that is sampling and quantization. And that is here. This is the image, okay, and this is the 2D image, that is f of x comma y, that is x in x comma y are pixel values in x position and y position, and first it should be converted into 1D image. So according to the gray value. So initially there is no picture, so here, so it is indicated here, and at the end there is no image, so here it is indicated. So according to the gray value, we have drawn a map, okay, and this is the sampling, and here there are different gray values. So mapping this discretization of spatial values to the different gray values is called quantization. So here we should know sampling rate, that is the number of samples per unit distance. Spatial resolution means detail captured in the image. Pixel size. Pixel is a smallest particle in the image. So highest resolution means we can get the very clear image. So there is a sampling effects, that is it should follow Nyquist rate. That is there is a condition that is called Nyquist rate. So if it does not meet it is called, the condition is called oversampling, that is higher resolution, more detail. And if it is otherwise it is undersampling, that is lower resolution, potential aliasing. So the sampling theorem should follow Nyquist-Shannon theorem. That is, minimum sampling rate is Fs. That is, Fs should be, sampling frequency should be greater than 2f max, maximum frequency. This is the original. This is the original signal, and the sample rate at twice the original signal, so that we can correctly reconstruct the image. So undersampling means Fs less than 2f max, that is higher frequencies appear at the lower frequencies. It causes distortion and loss of information. So we should follow the Nyquist-Shannon theorem. And this is the quantization. So number of quantization level is calculated and determined by 2 into bit depth. So if it is 8 bit, there are 250 levels of pixels, and if it is 16 bit, there are 65,536 levels. If it is a 24 bit picture image, it is 6.7 m colors. So quantization, next we should know what is quantization error. Difference between original and quantized, or false contouring, dithering. These are the quantization errors. So higher bit depth, uh, we can get better quality large file size. Lower bit depth, we can get reduced quality but smaller in file size. So storage space is minimized, and it is applicant dependent. So this is the three-step process, and here we are applying analog signal and it undergone to the sampling. So there are three processes involved: sample, quantize and encode. Here we are digitizing the amplitude and it is mapped to the, or round off to the gray value. So here we can get the, and it is encoded, that is binary, it is encoded in binary, and we can get the digital signal in the output. So analog signal is continuous in time and amplitude, and discrete time digital means that is sampling and quantization. After sampling and quantization, we can get the digitized information. So these are the important points. And the main applications are digital cameras, scanners, medical imaging, image compression. So these are the major applications of digital image processing. So image sampling and quantization is the process used in used in converting the analog image into digital image. So, there are three processes involved: sampling, quantization and encoding. So it should follow the Nyquist rate. And this is the assessment time. According to the Nyquist-Shannon sampling theorem, what is the minimum sampling rate required to avoid aliasing effect? That is twice the highest frequency. That is Fs greater than 2f max, maximum frequency.